All right, guys, this is just going to get you guys your first set of notes for the third unit that we're going to have this year. This is about imaginary complex numbers. So it's pretty quick, but it's one concept that is going to be really important from this point forward. So you have to be pretty good at simplifying these expressions and understanding this one key rule. So the student checklist here says that you're going to be able to simplify any power of I, which we haven't really talked about yet, such that I has an exponent of less than or equal to 3. And then you're going to also be able to simplify any expression to the point where there are no negative numbers under radicals. So we've had that in the past where you've left things as like the square root of negative 3. Not doing that anymore. We're going to have a way today that we're going to get rid of those radicals. So the first thing that I'm going to do is start with example A. It's just saying here I got to find the roots of the following function. So A is a quadratic. I would try to double bubble this, but I'm thinking of all my numbers that multiply to 5 and add to 4, and there aren't any real numbers that do this. So I'm going to have to use one of my other two methods. So just because you already know how to do this, I'm just going to speed through this, and you'll be able to see my work on how I found these two roots. All right, so the method that I used is obviously completing the square, where this blue number here is my b over 2 squared that I added to both sides. Then this side double bubbled and became x plus 2 times x plus 2, and so on and so forth. So now I have that x equals negative 2 plus or minus the square root of negative 1. And we know that the square root of negative 1 is not 1, right? Because 1 times 1 is 1, and negative 1 times negative 1 is 1. So there's no way that we can multiply a number by itself and get a negative. So this is where we need a rule. This is a really important rule. The square root of negative 1 is a number that we call I. It's imaginary, is why we use I. But I represents the square root of negative 1 anytime we have the square root of negative 1. And it's going to become something we can use even when we have the square root of negative 3 or the square root of negative 5. But in this case, we're going to start off right here by just beginning with this expression. Instead of x equals negative 2 plus or minus the square root of negative 1, it's going to be plus or minus I. And then I can break it down into my two roots. So my roots are that x equals negative 2 plus I and negative 2 minus I. This is a very important thing to box, circle, underline, whatever it is. It's got to be front and center on these notes. Because when you come back here, if you forget what I is, which I don't think you ever will after this point because we're going to use it so much, I'm hoping that you never forget that the square root of negative 1 is I. So let's investigate that a little bit further here. If we know that the square root of negative 1 equals I, then what's I squared? Well, then I squared would be the square root of negative 1 squared. We know from squaring things in the past, like 2, if I take the square root of it and square it, those two things cancel, and I'm just left with 2, right? So the square root of negative 1, if I square it, just equals negative 1. So that's a pretty important identity to remember here, and you should probably have that in your notes, that I squared equals negative 1. All right, now let's move on to I cubed. Well, that's going to be the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And the reason that I've written it this way is because we already have an identity for I squared, right? So we know that this square root of negative 1 squared is just going to become negative 1, and then we're going to be left with this other square root of negative 1. So the square root of negative 1 squared is negative 1, and the square root of negative 1 is I. So I cubed is just negative I. And we just multiply those two things. At this point, we're treating I like it's a variable, like x or y or something like that. Let's keep going. I to the 4th. Well, we have already defined something that's really going to help us here. I can rewrite I to the 4th as I squared times I squared. And remember that when you're multiplying two terms that have the same base, all you need to do is add the exponents. So this expression is equivalent here. But we have an identity already for I squared. What does I squared equal? It equals -1. So these are each negative ones. -1 times -1 is 1. So if we have I to the fourth, that's really the same as just 1, which is a nice thing to remember because that's going to help us out a lot in the future. In fact, if now I have I to the fifth, now I can just rewrite this as I to the fourth times I to the first because I'm adding my exponents. 4 plus 1 is 5. This is the same thing. And I know that I to the fourth equals 1. So this is really just the same as 1 times I, which is I. So you can see now that the cycle is going to start to repeat. I to the sixth is just going to end up equaling -1. I to the seventh is just going to end up equaling -I. And then we get back to I to the eighth, and we're back to it being a 1. The cycle of I is pretty important. So I'm going to draw a little visual over here so that we can see exactly what we just did. We have I, and if we were to square I, it would become a -1. Then if we multiply it by I again, it would become a -I. If we multiply that by I, it's going to become a +1. And if we multiply by that I again, we're just going to end up back at I. This cycle just keeps continuing. So anytime you can factor out an I to the fourth, you've done yourself a huge service because I to the fourth just equals 1. So I to the fourth is going to become our biggest friend here. All right, so this is going to be the first video of your notes on complex and imaginary numbers. And I'm going to post another one on YouTube that you should watch for C and D, but I'm only going to check that you watch this one on Edpuzzle.